So let's talk about the antilogarithms. Now, to get antilogarithm of a number, we simply apply the reverse process that was used in getting its log. An alternative method is by use of antilogarithm tables. So the following is an extract of a section of antilogarithm table, and we want to use it to find logarithm of some numbers. For example, in example 12, we are to find the antilogarithm of 0.8865. So here we start by checking the row with 0.88 and column under 6. So we are going to have 0.88 is here, under 6 we have that. So the row and column intersect at 7.691. In the difference column, we check under 5, and this one is here. So the digit there is 9. Therefore, the antilog of 0.8865 is 7.691 plus 9. That is the difference. And that would give us 7.700. So we can also use the antilog tables to find logs of the antilog of numbers where the characteristic is not 0. For example, if we have 3.8865, so from the tables we find the antilog of 0.8865, which we have found as 7.700, and then we multiply by 10 times 10 raised to power 3. So depending on the value of the characteristic of that number, we raise 10 to a power equivalent to the characteristic of the number whose antilog we are finding. So in this case, it will be 7.700 times 10 raised to power 3. That gives us 7,700. Let us now see how we can use logs and antilogs in computations. And our first case is we want to use the logarithm tables to evaluate 2.7 times 2.8. So here we are going to have each number with its log. So log of 2.7, remember, if we write 2.7 in standard form, it will be 2.7 times 10 power 0. So our characteristic is the power of 10, which in this case is 0. Point, the mantissa is now read directly from the table, and log of 2.7 is 0.4314. So if we combine the two, we are going to have 0.4314. 2.8 in standard form is 2.8 times 10 power 0, and therefore our characteristic will be 0. Then point. From the tables, log of 2.8 is 0.4472. So if we combine 0 and 0.4472, we have 0.4472. Now, since we said and we have seen previously that if the bases are the same, that is from the first law of indices, then we need to add the indices. So in this case, as we had mentioned, logs are powers, and therefore we add 0.4314 to 0.4472, which gives us 0.8786, and then we get the antilog of this number. And from the tables, you'll find that antilog of 0.8786 is 7.561, then times 10 raised to, our characteristic here is 0, so that would be 10 power 0. And therefore, the value is 7.561. Another case is we want to evaluate cube root of 0.02853 using logarithm tables. So here the number is 0.02853 raised to power third. From the tables, log of 0.02853 is bar 2.4553, and then we divide this by 3. Remember, the denominator here is 3, so we divide the log which we have read from the tables by 3. Now this involves a technique here which we may call it resolving logs. So if the number under the bar is not divisible by denominator, we adjust it to a value that is divisible by denominator. So in this case, 2 is not divisible by 3, and therefore we adjust it to the next number divisible by 3, which in this case is 3. So we are going to have bar 3 over 3 plus, remember, to adjust from bar 2 to bar 3, we need to subtract 1. And therefore, to create the balance, we add 1 to 0.4553, and that would give us 1.4553 divided by 3. So in this case, the value of the number is not changed. So therefore, by 3 divided by 3 is by 1. Then point. The characteristic, the mantissa in this case will be the result we get from dividing 1.4553 by 3, which is 0.4851. And therefore, our final step is to get the antilog. And antilog of by 1.4851 is 0.3056. So we can still look at another example where we have now several operations together. We want to use logarithm tables to evaluate cube root of 0.02853 divided by 2.7 times 2.8. So in our numerator, we have seen already worked out log of 0. So we have number log of 0.02853 power third is by 1.4851 from our previous example. Log of 2.7 is 0.4314. Log of 2.8 is 0.4472. So already that one we have worked out. So in the numerator, there is in the denominator we have multiplication. So we had the two logs, which will give us 0.8786. And therefore we subtract the log of the denominator from the log of the numerator, which will give us by 2.6065, and then we get the antilog. That would be our answer.